Hello friends, in today's question, a block of mass small m can slide freely along the vertical surface of a bigger block of mass capital M as in the figure. So this is mass capital M, this is mass small m, and it is able to slide freely along the surface of this capital M. The block M is connected to one end of the string whose other end is fixed at point P. So this is the fixed point of the string and the other part is connected to the small m mass m. The string between pulleys P1 and P is horizontal. Okay, so this is pulley P1 and this should be here P2. Okay, so this is pulley P1 and P2. The string between P1 and P2 is horizontal and other part of string are vertical. The system is released from the rest. Sorry, here it is P, my mistake. The string between P1, so this is pulley P1 is horizontal and other part is vertical. It means the string between P1 and P2 is vertical and between P2 and the mass M is also vertical. Find the acceleration of small and capital mass during subsequent motion. So in this case, let us divide this entire string into three parts. Okay, let's call this as first part, this is second part, and this is our third part. Okay, so we did dividing string in three parts. String 1, between mass M and P1. String 2, between P2 and P1, and we have string 3 that is between P1 and point P. Now when the system is released from the rest, mass M is going to move in the downward direction. Okay, so you can say as the system is released from rest, so first point, mass small m is going to move in downward direction. It is going to move in the downward direction. Okay, and because of which what will happen, and let us say it is going to move in the downward direction with acceleration small a. Okay, and secondly, because of this movement, the length of string 1 is going to increase. Okay, length of string 1 is going to increase. Now because of the movement of this mass M, the length of the string, the length of string 3 is going to decrease, okay. It is going to move in downward direction, so this length is going to increase, and because of this pulley, okay, the length of the string is going to decrease. Now because of this, what will happen, the length of the string 3 is going to decrease, so mass capital M is going to move toward the right. Okay, we can say that thus, the length of string is 1 is going to increase, and the length of the string 3 is going to decrease. Thus what will happen, the mass capital M is going to move towards right, okay. Let us say it is going to move towards the right with an acceleration of capital A, okay. It is going to move towards the right with the acceleration of capital A. Now because of this movement of mass M towards the right, the mass small m is also going to move right, okay. So because of which, therefore mass small m will also moves toward right with acceleration capital A, with acceleration of capital A, okay. So it means small m is going to have two acceleration, one in vertical direction and another one in the horizontal direction. And okay, let's draw the, you can see, find out the constant relationship between the accelerations or mass capital M and small m. So we already discussed that the small mass, capital mass is going to move to the right. So we say that let x be the distance through which mass m moves towards right. And you can say that let small x be the distance through which mass small m moves in downward direction. So we say that x moves towards the right by a distance of capital X. Let me write it here, capital X, okay, and mass m moves downward by a distance of small x, we said that capital mass M moves towards the right with the distance of capital X, and mass M small moves downward direction by distance of small x. So the distance which is moved by the string 3 will be also x, capital X rather, as it is only dependent upon the movement of mass capital M. Okay, we can say that the string 3 will be also moving with the distance x, capital X. Okay, the length of string 3 is dependent on the movement of mass capital M. Therefore the string 3 also gets the slack of capital X, but there will be no slack in the vertical string, that is string 2. So we can say that, but there is no slack in string 2 rather. So we can say that the net, and we already know that ideally there should be no slack in the entire string. Okay, so we can say that for slack to be 0 in the entire string, so slack in string 1 plus slack in string 2 plus slack in string 3 should be equal to 0. Now doing the algebraic sum, we can say that positive x plus 0 plus negative x is equal to 0. So from here x is equal to capital X, or double differentiating, let this be equation 1. Double differentiating equation 1, we get A is equal to capital A. So let this be equation number 2. Now let's draw the free body diagram of capital mass as well as small mass. Let us draw for the capital mass. So it's a pulley, and there is string in the downward direction here, and there is string connected here, and it goes like this through the pulley in this direction. This is T1, this is P1, P2, and we have tension T, and we are seeing that it is moving in this direction with acceleration A. Okay, and because of this mass small m, there will be normal in this direction. So we write the equations as the motion is only in the horizontal direction, so we only consider the equation for the only horizontal direction. Okay, so we can say that for free body diagram for capital M, we get T minus N is equal to mass into acceleration. Let this be equation number 3. And for small mass, see M, it is going in downward direction with mg. Okay, it is going to have two acceleration, one in downward direction by A and another one in horizontal direction, that is capital A, and there is a tension T which is acting in upward direction, and there will be a normal in this direction. So we can say that for FPD in small m, we get, so in this case we can draw because the motion in vertical as well as horizontal, so we are going to write two equations. One, we get N is equal to ma, let this be equation number 4, and another equation we are going to get, because of the vertical motion, mg minus t is equal to ma. Let this be equation number 5. We are going to solve all these 5 equations. So let me write these equations once again. We have an equation that A is equal to capital A, and we have the equations T minus N is equal to ma. This is equation number 2, this is equation number 3, and 4 is given as N is equal to ma. This is 4th equation, and 5th is given as mg minus t is equal to ma. This is our 5th equation. Okay. So we are going to use all these 5 equations. First of all, let's add equation number 3 and 5. Okay. Adding equation 3 and 5. So if we add them, we get mg minus n is equal to ma plus small ma, and now we put the value of normal from equation 4. So we can say that using equation 4, let us call this as 6. In equation 6, so we get mg minus ma is equal to ma plus small ma. So we can write from here mg is equal to, if we take capital A as common, we get m plus capital M plus small a, and we already know equation number 2, so we write using equation 2. Using equation 2, let us call this equation number 7. In equation 7, we get mg is equal to, if we put a, we get this is m plus a m plus ma, and you can say that mg is equal to 2ma plus am. We take a as common, we get this is 2m plus capital M, and from here we can write that A will be equal to mg divided by 2m plus capital M. Okay. So this is the acceleration of small m in the downward direction. Okay. So you can say that acceleration of mass m in downward direction, but we also know but A is equal to capital A. So we also say that this implies that capital A will be also equal to mg divided by 2m plus capital M. So this is the acceleration in the horizontal direction. Okay. This means acceleration of mass capital M in horizontal direction. But okay, we can say that but mass M moves vertically as well as horizontally. Moves vertically and horizontally. Okay, so it means if this is mass M, so it is moving horizontally by acceleration capital A, and in downward direction it is moving with a small a. So the net acceleration of this mass M will be somewhere here. Okay, so this is mass M. Therefore, net acceleration of mass M, that is equal to A net, will be equal to A square plus capital A square and its square root, and we can simply substitute the value. So we are going to get this as, if you put A is equal to this, so this will be 2 A square its square root. This can be written as A square root, and A net will be equal to square root, substitute value of A, that is mg divided by 2m plus capital M. This is the net acceleration of mass small m. Thank you.